To solve a right triangle means to find all three side lengths and the measures of all three angles. Certainly we know one of the angles is 90 degrees, so we're really just looking for the two acute angles. In this triangle, I'm given two side lengths, but neither acute angle. We can use those two sides that we know to find the measure of one of the acute angles. So pick your favorite, it doesn't really matter which one you choose. I'm going to pick angle S down here. For angle S, I'm going to notice that 25 is its adjacent side and 48 is the hypotenuse. The trig function that uses the adjacent side and the hypotenuse is the cosine. So I know that the cosine of angle S is its adjacent side over the hypotenuse. If I want angle S, then I can use an inverse trig function. S is the arc cosine, or the inverse cosine of this value. In these application type problems, we do generally use degrees, so make sure you're in degree mode. I'm going to do the inverse cosine of 25 over 48 and come out with measure of angle S is 58.61 degrees, and that's rounded to 2 decimal places. Okay, 1 down, 2 to go. Once I have one of the acute angles, the other acute angle we can get by subtraction. There's 180 degrees in every triangle. This is a right triangle, so 90 of its degrees are already taken up in the right angle. So angle T I can find by subtracting 90 minus angle S and find that angle T has a measure of 31.39 degrees. All we need now is the third side. When I know two sides of a right triangle and I want the third side, Pythagoras is the way to go. So 48 is the hypotenuse. That's the one that's by itself. 48 squared equals 25 squared plus, that's an S squared. We'll square, we'll subtract, we'll take a square root. And you use a calculator, certainly do that in whatever configuration that you like to come out with the length of side S, which should be 40.98 of whatever units we're measuring, and it doesn't say. And we have just solved that right triangle.